explanation of a linear system of equations question. I know that it's linear because we have two expressions that are linear. So the way I know that they're linear is because they have y equals mx plus b as their general structure. So what I'm going to do is I'm just going to look at the slopes of these expressions. So all I do to figure that out is I just distribute the -3 here. That gives me -3x as my slope for my line on the left side. And on the right side, I don't have to distribute or expand or do anything. I just see that the slope is 3x. The rule is if we have lines with different slopes, you automatically have one solution. So that's the only possible outcome here. It's one solution because you have different slopes. Let's look at our decision tree for linear expressions. So our decision tree tells us that if the slopes are different, if the answer is yes, even if it's -3x and +3x, our answer is one solution. Think about how lines work. A line goes on forever and ever. So if you have different slopes, I'll just draw another line here. If you have different slopes, they're going to intersect at exactly one point. That's the end of the story there. If the slopes are different, it's one solution. Let's look at the rest of the decision tree. So if you have different slopes, the answer to, are the slopes different? The answer is no. So they have the same slope. Then you have two different outcomes. The first outcome is if you have a different y-intercept, that means that you have parallel lines, which I've drawn a rough sketch of here. So you'd have your blue line and your red line. They have the same slope, meaning that they're parallel. They extend forever and ever in both directions, and they never intersect each other. They have same slope, different y-intercept, different b term, and y equals mx plus b. The other outcome you could have is if the value of b is the same, then these are the same exact line. That's why I've marked that in purple. Imagine that your blue and your red line are just the exact same line, same slope, same y-intercept. That means it's the same line, and you're going to have infinitely many solutions. Let's say that you had the same basic question, but when you expanded the left side of the equation, you found that you had an expression like this. You had -3x plus 4 equals -3x plus 4. Your slopes and your y-intercepts are identical. That means you have the exact same line. And when you have line equals the same exact information, then that means that there are infinitely many solutions to that system of equations. If you only had these answer choices, you would have to select answer choice D. The most accurate answer to this question would be that there are infinitely many solutions because your slope and your y-intercept are identical. But answer choice D is the only thing that you could pick here because they did not offer infinitely many as an option. I'll make a video with more examples of this where we have all three possible outcomes. So I'll have answers where the answer is one solution, no solution, and infinitely many solutions. In a future video, I'll go over this question, which is a system including a quadratic equation and a linear expression. Notice that the answer choices are reminiscent of our answer choices for this linear system. I'll also show you how you could use Desmos to graph the situation so that you can find the point of intersection for the parabola and the line. I will also make a future video about the discriminant. This is a discriminant question, and notice that the language is similar to the answer choices in our question about a linear system. It says, if this equation has no real solutions, which of the following could be the value of t? So to solve this question, you need to understand the discriminant. You need to understand that if we're pulling those a, b, and c values from a quadratic equation, we first need it in standard form. So we'll go through all of that so that you can be confident about your ability to answer these discriminant questions, and then you'll be in good shape for your SAT. This question type has also appeared on the ACT. The ACT has even had questions that required that first you use synthetic division or your calculator to factor an expression that began with a power greater than 2, and then you had to work off of a quadratic equation. So if you are preparing for the ACT, this information will be important on that test as well.